Jai Hind all of you. Myself Deepti Arora, Assistant Professor MCA. Today we are talking about TCP connection, that is three-way handshaking. TCP connection. We have studied two protocols earlier, that is the UDP protocol, TCP protocol and SCTP protocol. Three protocols are used in transport layer. The three protocols are there. One is UDP, next one is TCP and third one is SCTP. UDP is totally connectionless protocol, while TCP and SCTP both are connection-oriented protocol. So TCP is our connection-oriented protocol in which we are making a connection in both the client and the server, or we can say between two hosts. Suppose we are having two hosts, host A and B, and we have to transfer data between them. So first we have to make a connection between them so that we can ensure that the data transfer is reliable, it's trustworthy, and it is free from errors. So to transfer data, we create a virtual path between the source and the destination. Between source and destination, we have to create a virtual path using virtual circuit. Using virtual circuit. Now what is virtual circuit? Virtual circuit is, suppose we are having hosts here and we have to transfer data between any of the two hosts. Suppose we are taking this host and this one. We have to transfer the data. So there are many links between each of these hosts. We have to transfer the data. So we make a logical path between these two in which we see that there is minimum congestion there. So we create a virtual circuit between them, and by creating a virtual circuit, we have created a virtual path, a logical path between the source and the destination. And using that virtual path, TCP transfers the data from host A to host B or from source to destination. Now, all the segments. What are segments? Segment is a packet in transport layer. In transport layer, a packet is known as segment. So all the segments belong to a message are then sent over this virtual path. Using this virtual path, we transferred our segment or packet. Using a single virtual path for the entire message facilitates the acknowledgement process as well as the retransmission of damaged or lost frames, or we can say lost segments. That is, we are having only a single path, that is a virtual path. Again, that is a full duplex. That is, the data can be transferred from A to B or B to A in both directions. So we are having a logical path as well as the full duplex path. TCP uses the services of IP. IP is Internet Protocol, which is totally connectionless protocol. You are using here totally connectionless protocol IP, and over that IP that is used in network layer, in transport layer, we are using TCP, which is fully connection oriented. The point is that TCP connection is virtual, not physical. Virtual means logical, not physical, because physical connection is only made at physical layer. So in transport layer, we are transferring the data, we are making the connection, but it is totally logical connection. Again, TCP operates at higher level in which the data is transferred, and TCP uses the services of IP to deliver individual segments. Again, segments are packets to the receiver. In TCP, the connection-oriented transmission requires three phases. The first one is connection establishment. So we are making the connection first, then we do the data transfer, and then we terminate the connection. So to make the connection or to transfer the data and then to terminate the connection, we use a process known as three-way handshaking. This is a process to transfer data using three-way handshaking, in which the first step is connection creation. Then second step is data transfer, and third step is connection termination. Three steps are there. So I am starting with the first one, that is connection establishment. So in connection establishment, we have two things. Firstly, the process starts with the server. We start with the server. The server program tells its TCP which is ready to accept the connection. It tells the server, tells that its TCP, that is transmission control protocol, that it is ready to create a connection. So this request which the server creates for the TCP protocol is known as passive open. It creates a request, server creates a request to its TCP protocol which is known as passive open. Now, server is ready to accept any connection over the word, but now it has to create a connection, it has to create a logical connection. So it creates a request known as passive open. Now again, the client also issues, because it's a full duplex mode. So in both way, the connection has to be made. Both way, the connection has to be accepted. Only then the data can be transferred. So TCP client program also issues a request which is known as active open. See in the diagram, this is the client, this is the server, and the server creates a passive open request to TCP protocol and the client creates a active open request to make a connection. Now, TCP now starts a three-way handshaking process after creating a connection. Request is sent. Now how the connection is made, handshaking process is done. See, this is a segment. Segment is again, we can say a packet or TCP, a transport layer. So this is a segment. It is the sequence number of a packet so that data can be transferred. So every segment is having its own sequence number, and that sequence number is incremented by 1 when it transfers the data. So here the sequence number is 8000. Now it has to synchronize that data with the server. So it is sending the synchronized segment. Again, SYN stands for synchronized, and this S represents the synchronization flag. So it is activated, synchronization flag is activated, that it is 1. Otherwise, it will be 0. So synchronization flag is activated. So it is written S here. Again, it wants the acknowledgement of this segment. So it is sending also A here, that it wants the acknowledgement of this packet. So it is initializing the acknowledgement flag also. The segment is here with the sequence number 8000. It is not having any kind of data in it. It is only for connection made. That is for active open state. It is sending a request packet, that is a segment with sequence number 8000 having acknowledgement and synchronization flag set to 1. Imaginary byte 1 is to be sent here. We are not having any data here, but we can say that synchronization segment carries no real data, but we can think of it as containing one imaginary byte. Imaginary byte, not the actual data is here. So it is sending the packet. Here it receives, the server receives it. Again, it sends the acknowledgement plus acknowledged and synchronized packet. Because it is the full duplex mode, the server also sends back the data. Now, the server sending the segment, it is having sequence number 15,000 and it is acknowledging the previous segment sent by the client. So, in acknowledgement, the sequence number is 8001, which is sequence number 8000. So, it is incremented by 1, 8000 plus 1. So, acknowledgement is having the sequence number 8001. Again, it is synchronization plus acknowledgement. It is piggybacking synchronized plus acknowledgement. So, both are there. So, it is piggybacking synchronization segment with acknowledgement segment. Here again also it wants the acknowledgement. So, it is having acknowledgement flag set to 1 and synchronization flag set to 1. Now, again, the client sends back the acknowledgement to the server. It is using the sequence number 8000. Now, see, it has sent, server has sent back the acknowledgement. So, it is having sequence number increased by 1. But here, no data is transferred, only the acknowledgement is sent. So what it is doing, the synchronization sequence number is same in the next segment also, because no data is transferred, only the acknowledgement of the previous segment is sending. So no increment in the sequence number sent by the client. Again, it is acknowledging the sequence segment of server segment. So it is the sequence number of acknowledgement is increased by 1, which is 15,001. Again, acknowledgement segment is here. So acknowledgement is set, flag is set to 1. Now what is simultaneous open? Here the connection is made, connection establishment is done, that is the first phase is completed. Now what can be the situation in this phase, simultaneous open? In simultaneous open, both the client and the server make the same request of connection establishment at the same time. A rare situation called simultaneous open. In this, both processes, that is the client as well as the server, issues an active open state. That is, again, any could be the host can be the client and any host can be the server. So anytime server want to make a connection with the client or client want to make a server with the connection with the server. So in a rare situation, what can happen? Both the client and the server make the same request at the same time, that is the active open state. That is, server also want to make a connection with client and client also want to make a connection with server. So in this case, both TCP can simultaneously send synchronization plus acknowledgement segment, that is this segment, simultaneously to each other, and one single connection is established between them. So no need to send 3 packets between them. They both can send one packet to each other, that is this packet, and the connection is established between the client and the server. Now, again, the next problem occur here is synchronization flooding attack. What is synchronization flooding attack? It is similar to denial of service attack. What is denial of service attack? In which the packets are sent on the network so that the path, the virtual path created between the host is got congested and no data transfer can be held between them. That is, a malicious attacker attack on the network, sends the packets there that is of no use and make the route congested. Similarly, in what is in synchronization flooding attack? In synchronization flooding attack, the TCP connection is going to be made, in which what it sends the synchronized packets to make a connection. When the synchronized packet is sent, the server, what the server do? Server creates a virtual path between the client and the server. It is sending the acknowledgement packet. The TCP server sends the synchronization and acknowledgement packets again and again. But what the malicious attacker will do? It will not accept this packet here. What is this here? In active open state, here there is no client. Here is a malicious attacker. What malicious attacker is doing? It is sending the synchronization packets again and again and again. And when the server is sending back the acknowledgements, it is not accepting that acknowledgement packet. So when it is not accepting that synchronization and acknowledgement packet, what will happen? No connection could be made because it will not sending back the acknowledgement packet. What the server will do? Server will send the packet and reserve. What? It will reserve all the resources that is used to transfer the data between the server and the client. So it will reserve all the resources. A virtual path will be created. All the resources will get reserved, and this malicious attacker is sending the synchronization packet again and again, making the virtual path congested. So what will happen? The no connection is made. The malicious attacker is sending the segments which make the virtual path congested. All the resources got reserved, but nothing is happening. No data transfer is going to take place. So this is known as synchronization flooding attack. Now, what is data transfer? How the data transfer? This is the second phase of TCP connection. We have discussed about TCP establishment, connection establishment in three-way handshaking process, in which we find there are two problems that can occur here. First one is simultaneous open, and second one is synchronization flooding attack, which has been overtaken by SCTP protocol. Both of these situations can be handled by SCTP, which cannot be handled by TCP. So the next phase is now data transfer, how the data transfer take place at TCP connection. Now the connection is established, the actual data transfer is going to happen here. Now in this data transfer, we are taking an example that after the connection is established, the client want to send 2000 bytes of data in two segments. That is, two segments, it want to send 2000 bytes of data. It will first send 1000 bytes and again it will send 1000 bytes. The server sends 2000 bytes in one segment. Server also sends the data, but it sends 2000 bytes in one segment only. That is, it is creating two packets known as segment, and the server is sending back the 2000 bytes only in one packet, or we can say one segment. Then the client sends one more segment, that is the acknowledgement segment. The first three segments carry both data and acknowledgement, because data is sent and then acknowledgement is sent, so it is piggybacked in one packet. While the last segment carries only an acknowledgement because there is no more data to be sent. Data is sent by the client, have the push PSH flag set so that the TCP knows to deliver the data to the server process as soon as it is received, while the segment from the server does not send the push flag because it does not want to send the data, it only send the acknowledgement. So the data transfer process can be understood by this diagram. See here. Here is a client process which is at client transport layer. Here is a server which is at server transport layer. Server uses A as acknowledgement flag and client uses P as push flag. So the first connection is established, that is active open and passive open state has been done. Now actual data is transferring now. Send request. It is sending a segment with sequence number 8001. Now why sequence number 8001? Because in synchronization segment packet, it sends the sequence number 8000. So now for data transfer, the sequence number is incremented by 1. It becomes 8001. Again, acknowledgement is 15001. See here. 15001, that was only for correction establishment, that is acknowledgement packet. Now we are actually transferring the data, so acknowledgement of the previous packet was written here, 15001. Acknowledgement flag is set and push flag is set because data needs to be transferred. So push flag is set, we need to push the data, so push flag is set to 1. Now what is data? It is carrying bytes 8001 to 9000, that is 1000 bytes, as we have discussed that it is sending 1000 plus 1000, two packets are there of 1000 bytes plus 1000 bytes. So first packet is there, again sequence number 9001 incremented, 9001. Why? Because 1000 bytes are transferred with the sequence number 8001 to 9000. Okay, now the sequence number is 9001. Again, the acknowledgement, we have not received the acknowledgement till now. It is of previous acknowledgement, so it is again 15001. Acknowledgement and push flag are set to 1. The data is in bytes now from 9000 to 10,000. Again, 1000 bytes of data is here. Now, the server received these segments. Now it is sending the request. Now the server is sending the data, acknowledged is piggybacked with the synchronized packet. Sequence number 15001. Why 15001? Because 10,000 is here. Acknowledging, it is sending its own sequence number now. Sequence 15001 which got acknowledged previously. Now acknowledging this packet 1001. So it is 10,001 acknowledged sequence number. Acknowledgement it wants. Then receiver window size is 3000. That it does not want to send the further data. So it is sending the receiver window size. So that is 3000. Data is 2000 bytes. So 15,000 to 17,000, that is 2000 bytes. Now it has received the data packet. Now it is sending again the request, sequence number 10,001, which was the previous number, and acknowledgement of 17,001 because the last was the 17,000. So it is acknowledging 17,001 as sequence number, again acknowledged, and receiver window size is 10,000. It tells it got received. Now what would happen? Connection will get terminate here. So this is the process how data got transferred at TCP layer. TCP connection using three-way handshaking. Now pushing data. Again, there were two things when we have created a connection. That was the simultaneous open and synchronization flooding attack. Again, two problems are here also in data transfer. First one is pushing data and second one is urgent data. Pushing data. Listen. Sometimes happen that we want to send the data that wants an immediate response. So what would be done at that time? For example, when an application programs on one side want to send a keystroke. Keystroke means when the client or application programs pushes a button or clicks on a button or sends some data immediately, what it happens, it wants that TCP would receive an immediate response. It sends a request and it wants an immediate response from the TCP or from the client or server. What would TCP do at that time? It requests a push operation. In push operation, what it does, it set the push bit set and let the TCP know that that segment include the data that must be delivered from receiving application as soon as it is possible and not to wait for more data to come. That is, the TCP maintains a queue buffer. It is having a circular queue buffer, or we can having a circular array, which is a queue, and it buffers that data at both sides, at client as well as at server side. So what happens when TCP transfers the data in segments, it stores or buffers the data in a queue. Now it sends the data and pushes the data one by one to the server. If client is sending the data to the server, the client TCP using the buffer pushes the data one by one. But what happens, suppose the data is present here and the application program want the data to be immediately come to the server. So what happens, it sets the push flag set to 1 again and wants that this data is received to the server as soon as it is received at the TCP. It is not inserted in the queue, but it will, as soon as it receives at the TCP, it does not enter the queue and sends the data to the server. That is the pushing data. Now what is urgent data? Sometimes at application layer, the program needs to handle the sends to the urgent data, want to send some urgent data which need to be responded immediately. At that situation, what TCP does? Suppose that the sending application program is sending data to be processed by the receiving application program. That is to be processed by receiving application program, and the sending application program sends the data. As the resulting of process, it sends that the application program find that everything is wrong. That the sending application program finds that at the receiving end, everything is wrong. Nothing is right, nothing is received exactly what it wants to send. So what it does, it sends the urgent flag byte. Urgent flag byte sends to 1. If it doesn't send so, what would happen? All the virtual path space, all the resources got waste, all the virtual path that is made, all the time has been wasted, and what would be the application program, receiving application program will receive, that is the wrong data it would receive. So what will happen? It will send the urgent flag set to 1, that is immediately stop that data, don't process that data, it would be receiving as a wrong data. So don't stop that data for further processing. So that is, we use the urgent data, that is urgent flag set to 1. So for both situation, that is when the urgent data is sent and when the data that requires the immediate response, we have two flags, that is push flag and the urgent flag. When we want to send the urgent data, urgent flag is set to 1, and we want to send the push data, that is push flag is set to 1. Now the last one, connection termination. In connection termination, the third situation is, that is we are having the fin, that is finished packet. In connection establishment, we are using the synchronization, that is SYN packet, SYN segment. Here we are using the finished segment. So F for fin, for finish flag, and acknowledgement A flag. So now here the client initiates the active close state and the server initiates the passive close. In that case, we are having active open and active close. Now we are having active open and passive open. Now we are having active close and passive close. So in finished packet, again it is sending the sequence number X, acknowledgement Y with A and F set to 1. It is sending again sequence number Y, again the new sequence number from the server, and acknowledging the server's client sequence number with X plus 1 incremented by 1. Again acknowledgement and finish set to 1. And at last the client is sending the sequence number X with acknowledgement of this Y plus 1 incremented by 1, and it is only the acknowledgement packet with the imaginary byte 1. So it is sending the last finished packet, that is the acknowledgement packet. This is the example of how the TCP connection termination is done. So this is a process in which is a three-way handshaking process in which the TCP is reliable of sending data with full error and flow control using this TCP connection three-way handshaking process. So there are three steps we have discussed. First one is TCP connection establishment, then second one is data transfer, and third one is connection termination. So these were the 3 steps in three-way handshaking process in TCP. Next class we will discuss the further topics. Thank you.